All right, so like I said, most of what this is review. So this is nothing new. This is all, hey, yeah, remember all this stuff that we learned? We did it at the beginning of the year, so it should be fairly straightforward. We all know what the number line is, right? And then we know all the types of numbers that go on the number line. We've had this discussion. The set of real numbers are all the points on this line. Each real number is exactly 1 point on the line, and the collection of them make the line, so no big deal. How many points are there between 1 and 3 on the number line? Infinite. You cannot count how many numbers there are between 1 and 3. How many real numbers are there between 1 and 1 point, a gazillion zeros and 1? Infinity. How about infinite? Infinite. Okay. As opposed to finite. If we were going to plot the numbers on the number line, you should be able to have some reasonable understanding of where numbers are. Here's your 2, here's your 2.5. Where's square root of 5? About 2.3. It's more than 2, but less than 3, closer to 2 kind of idea. So maybe I'll put that one in green. So ish, somewhere around in there. You don't have to be close. This is not perfectionism. It's get yourself in the ballpark when you're doing it. 1 to the 5th. Oh yeah, that's 1. Doesn't really matter if I add a power onto it. Pi, 3.14-ish, so somewhere over there. -1 and -1.3. Where should I put -1.3? Left or right of -1? Left of -1. Understanding your negative numbers and knowing that the bigger quote-unquote negative numbers more to the left, so -10 is smaller than -5, that kind of stuff. That there is order on the number line, so we do want to pay attention to that. And we know that there are basically, if you're comparing two numbers on the number line, you have 3 choices. Either they are in the same spot, one is less than the other, or one is greater than the other. In this case, same location. This one would be A is which way, how is it related to B on the number line? So it's to the left. A is left of B. And this one would be A is right of B. And in the order on the number line, how do I tell if A is less than B? If I subtract B minus A and A is left of B, what happens? You get a positive number. And then if you have A is right of B and I do B minus A, I get a negative number. All right? So pretty straightforward, nothing you didn't know. Notation-wise, you have inequality notation, all these different choices over here. Remember our interval notation that we did at the beginning of the year with sets? That this is the kind of when we're solving, this will be kind of our answer that we get, like x equals 5 is our answer. This is our 2 ways of writing the set or solution set. We can either write it in interval notation, and when do we use interval notation? Only for intervals of what kind of numbers? Real numbers. You can also write it using the set builder notation. However, I will say that we'll put a star by this one. This is preferred. Anytime that we have a interval of real numbers, we want our solution sets written as intervals. And a lot of times what we'll do now is we start doing a graph of the solution set to kind of describe what's going on. We did it a little bit of graphing solution sets with the absolute value because you can graph the points that satisfy the distance equation that you have. But here, if I do A to B, not including A and B, what would I do on the number line? Well, A is clearly left of B. Is everybody okay with that part? That there is order understood in this, and we always go from smallest to largest. And there's 2 options. In middle school, what could you have put here to denote that I don't want to include A? Open circle, and then you would shade in between, and then you would put an open circle. Okay? That's option number 1 if you don't want to include. They will start doing the same problem, and instead of using open circles, and what do you use for include? Closed circle. Instead of doing that, the other option that we start to do, mostly because we like our interval notation, is they'll actually put parentheses to denote that it's open instead of the open circle and shade like this. And usually, I mean, it's either one or the other. I'll take both. But when you're doing this, a lot of times now we like to do the parentheses for open, and then what would I use for closed? The brackets, mostly because it matches the interval notation, so it's almost like you're reading your solution right off of it. So this would be open. If I wanted to do A to B half open, right? You want to be pessimistic or optimistic, half open versus half closed. You would have your A and your B, and I'm going to start using the brackets and parentheses. You just be like, hey, parentheses, shade, and your bracket for your solution set. Oh yeah, I'm looking, this one's this one. I'll fix it. That one is closed, open. This one would be open, closed, A to B. Closed. I don't even know why. It's almost just like I should have a picture of it and not have to actually draw it each time. I'm lazy. So we get that in. What do I do for this one? How should I shade that one? Yeah, start at A and just shade the whole thing. Just put another arrow on the end, kind of stop it short. You just have to be clear that you can see it. Sometimes when we're doing this section, we kind of like to have colors because it makes it easier to see what we have going on. So there would be our less than A version of that. So your job when you're doing this section is they're going to ask you to solve an inequality, which you'll get to an answer that looks like this. They will then ask you to write your solution set in interval notation, which means they want you to do this. If they just say solution set, an alternative for your solution set is to do that. And then they might ask you to sketch your solution, which means do that. All right? Pretty easy, straightforward, not much going on. All right, so sketching this one, open or closed? Closed, so here's your 3. Just eyeball where your 3 is. Which way should my bracket face, to the left or to the right? To the left. I'm shading all points less than or equal to 3, so we put our square bracket facing to the left. We're going to shade all points going this way. So that would be our picture of my solution set. If I was going to write it in set notation, I would do the set of all x such that x is less than or equal to 3. What's the difference between this and this? This is a set, and that's an answer. If I had done an equation solving and I got x equal to 3 as my answer, what would you write for your solution set? Right? You could do that to make it a set. That's the only difference. That's what we're doing. We're saying, hey, I got this answer. This is what the picture of the set looks like. Here's what the set is. Or, if I do interval notation, negative infinity to 3 with a bracket. Kind of as a note, you always put open parentheses on infinity and negative infinity because you can't equal infinity. It's a destination. So that's always an open parenthesis. This is called a compound inequality, which is called a conjunction. I want to think of it like that. In English, what's a conjunction? And. So when we write this in this compound inequality, we understand that this means and. What we mean by this is we would say x is greater than or equal to negative 3 and x is less than 2. What does and mean when you're combining sets together? What are you basically looking for? The intersection, where they are both true. So while x greater than or equal to negative 3 would start at negative 3 and shade everything up, I'm not going to keep going because I only want to shade where both of these are true. So I want to be in between, all points in between negative 3 and 2. And do I want to include, which endpoint do I want to include? Negative 3, so let's do a bracket, shade, and then R2. So that's the picture of the set that this solution is describing. In my set notation, again, it's not really any different. You would say set of all x such that negative 3 less than or equal to x less than 2. And then in your interval notation, bracket, -3 to 2, parenthesis. So both of these would be describing your solution set, and here was your picture of your solution set. Pretty straightforward. Right? When you get down to this next example, this is an OR statement. Okay? This is called a disjunction. And what I want to forestall is please do not write this so that it looks like a compound statement. A common mistake that I see, and this is incorrect, so don't write it down, is you guys go x is less than 5 and then greater than 10. Does everybody see a problem with that? Can x be in between 5? Is that what this means? See, this means x is in between 5 and 10, but this is weird. You've got bad symbols going on here. This does not work. This is completely incorrect. You cannot write a disjunction as a conjunction because they mean two completely different things. So if you're doing an OR, here's your 5. So somewhat, here's 5. And this is shading x less than 5. This is shading x greater than 10. What does OR mean when we do our sets? If AND is intersection, what's OR? Union. So union, remember, means we're just combining them together into one set. So we're basically taking everything less than 5 and shading that, and then everything greater than 10 and shading that. And do you see how the disjunction looks a lot different than the conjunction? Conjunction in between, disjunction goes out. Yes? Nope. So it's pretty much just kind of, for this one I am kind of estimating, but you don't always have to. You just make it nice. What's more important is that you have 5 and 10 and then shade the right way. That's really what we're looking at. All right? So our set notation, pretty much when we do that, there's nothing to do, but you have to write it or x greater than 10. Do not put it together into a conjunction because it's not a conjunction. Disjunction, remember when we did sets? These two sets are what kind of sets? They have nothing in common. Didn't we talk about that? Disjoint sets? So disjunction, disjoint sets, they have nothing in common. So that's kind of what we're looking at. We're combining two sets together that have nothing in common. Interval notation, what do I put in between these two sets that have nothing in common? Do the union, 10 to infinity. So that would be how you would write your solution sets for that. That the only way is I have two disjoint sets. The only way to combine them together is with union, and I can't do anything else to that. All right, so those are the three types that you're going to see. Now, when you are solving equations, you will sometimes get some weird answers because, like, we did absolute value, you had two things going on. So it might be possible we have two inequalities coming down that we're solving at the same time that are related to each other. So we might end up with an answer that says x less than 10 from one side and x is greater than 5 from over here. And if the word and is between them, what does this mean when I say x less than 10 and, I immediately go, I'm looking for the intersection of these two. What would be the intersection of x less than 10 and x greater than 5? What does that really mean? Is that a conjunction? Yeah. If x is greater than 5, you would never leave your answer written like this. You would be like, oh, hey, that's just a conjunction. That's in between. That's just saying x is in between 5 and 10. You would immediately convert it to the simplified version of the set notation. And so we would go x such that 5 is less than x is less than 10. Our picture, when we're drawing it, 5 to 10, and we would shade in between. And our interval notation would be 5 to 10. Notice that this idea is that when I see this, you should always simplify as much as possible. So you would never leave your answer in this notation. You would automatically combine them together using your knowledge of union and intersection. All right, what about this next one? Now I have x greater than 5 or x less than 10. What's or mean? Union. So now I'm doing the union, and so if I shade everything greater than 5, and then I shade everything less than 10, and I'm doing the union of them, what set is that? That's all real numbers. That's negative infinity to infinity. We don't really have a good inequality notation for negative infinity to infinity. I will say that some textbooks do this, and I don't like it, but it kind of accepted, okay? That really means everything. We really prefer to use our interval notation or our set notation. Interval is easy, negative infinity to infinity. Set notation, what would be the easiest way to say, hey, I'm including everything? What's a good set notation? X such that, well, X is an element. X is an element of all real numbers, so we'll use the little R symbol. Or we would even take the little special symbol, we'll just let you do that, because it's everything. So, well, instead of doing set builder, we'll just say, oh, we'll use that special symbol. It's everything, all the real numbers. And shading my picture, what should I do? Shade the whole thing. So you have to show something to show that you're shading something. So I usually just make it a little bit smaller, do this, and then do that. Because I want to make sure that there's a difference between something and nothing. So I want to make sure there's something shaded on there. Nope. Because when you combine them together, it's everything. So it doesn't really matter where 5 and 10 is. All right, now let's take a look at the last example. If I was solving an inequality and I ended up with x greater than 10 and x less than 5, and means intersection. So what happens in that case? If I shade everything greater than 5, or greater than 10, and I'm shading everything less than 5, and I'm looking for the intersection, there is no intersection. So what is my solution set? Null set. So set notation, we could do this, or we could do that, because it's empty. There's no intersection for those. Do not tell me that my solution is x such that x greater than 10 and x. Don't do that, because I'm going to take off, because your job is to interpret these answers to what they mean. So you should automatically go, well, that's nothing. Interval notation. What do you have to have in order to do interval notation? I have to have an interval of real numbers. Do I have an interval of real numbers? I have an interval of nothing. Don't make up an interval notation. Don't try to do like parentheses, parentheses with nothing in between. That doesn't work. This is not applicable because you cannot do interval notation when you have no interval of numbers to do. So it doesn't make any sense. We would never write the answer in interval notation. We would simply use the set notation. And then what would I draw on the number line? Nothing, because there is no solution, so there is nothing to shade on the number line. All right, and again, so like the moral of this is basically, if you are solving an equation and you get one of these three cases, then we're fine with that answer, because that's three just generic random, or generic typical solutions. If we get something like these three, we are not going to leave them like that. We are going to interpret them to what the actual solution is so that we understand what we're actually shading. Okay? All right, next page. All right, so solving linear inequalities. Now, I want you to underline for yourself that when we are solving linear inequalities, that we highlight the fact that this only works for linear inequalities. There are going to be kind of unfortunately in your guys' version of math, you guys learn one technique and then you want to apply that technique to work for all types of things that you see, because you're like, hey, it worked for the linear ones, why doesn't it work for quadratic or rational or square root inequalities? And yeah, guess what? This is the stuff you do only for linear, okay? Once we leave linear behind, we have to talk about different strategies for solving quadratics and rationals and radicals and all that stuff. This is only linear. These are the easy ones. It'd be nice if the easy technique worked for them all, but it doesn't, okay? So, but in general, things that you can do with your inequalities that are considered to be okay, I can add or subtract a number to both sides. Everybody okay with that? Because if a is less is left of B, and then I take both of them, adding a number to it means pick them both up and move them the same distance down the number line, put them back down. Are they still left of each other? Yes. It preserves the relationship. So this is perfectly fine, no problems. I can add or subtract to both sides. Can I multiply or divide by a positive number? And that doesn't change the relationship. If A is left of B, and I multiply by a positive number, A, if it's positive, will move more this way. Let's take a look at cases. This is what I want to make sure we pay attention to when we're looking at. If I have a number line, here's 0. If A is here and B is here, and suppose I multiply them both by 5, what happens to them? A moves this way, 5 times the distance from 0. B moves that way, 5 times the distance from 0. If I compare 5A to 5B, is 5A still left of 5B? Okay, so that works out okay. What if I had A and B not on the positive side? What if this was 0 and A was a negative number? What does 5 times A do if A is negative? Which way does it move it? It moves it to the left. 5 times the distance from 0 going in the left direction. B, 5 times B would move it 5 times in the right direction. Are they still 5A left of 5B? So we preserve the inequality, nothing changes. And if they were both on the same side, if B was here, instead of on the positive side, if I multiply by 5, would you still preserve the 5A would be left of 5B, right? So that's multiplication or division by a positive number. That works out just fine, okay? Now, what about if we have multiplication or division of a negative number? And that's, it's kind of, you know what you're supposed to do. If you multiply or divide by negative, you do what? Flip the sign. Why do we do that? All right, let's take a look at the simple case. Let's put A and B both positive. Here's 0, here's A, here's B. I am going to multiply by a negative number. What happens to A? Where does A times a negative number go? Right now it's above 0. It goes below 0. So say we multiply by negative 1, wouldn't negative A end up on the negative side? And where would negative B end up? On the negative side. Oh, look, A was left of B, but once I multiplied by the negative, now I'm no longer left, it's now right. Does you see why you're flipping the sign? That's why we flip the sign, because they changed position when you multiply by a negative. And that's true whether they're on the same side, on opposite sides of 0, or on the negative side, right? So we always have to remember to switch the sign, if you multiply or divide by negative. All right? We all understand transitivity, right? If A is left of B and B is left of C, then clearly A is left of C, so we got that down. And then reversal, if A is left of B, then B is right of A. Means the same thing. All right? Now, I am going to put a star by this one, because this is the one thing that you have to be careful of. Right? If I had, and the reason I'm putting a star, notice that it says by a negative number. Can I multiply both sides of an inequality by x? What do we know about x? Do you know anything about x? Do you know if x is positive or negative? Do you do something different if it's positive than you do when it's negative? But yet you don't know if it's positive or negative. And so if you were going to try to multiply both sides of an inequality by x, I'm going to look at you and say, are you supposed to switch the sign? You're not supposed to switch the sign. How do you know? You don't. You cannot multiply or divide by a variable. I cannot stress this enough. Because unless you know the variable is positive or unless you know it's negative, you don't know whether or not you can switch the sign. This is the most common mistake that we see in inequalities. Because could I multiply both sides of an equation by x? Yeah, it worked for equations. Well, why won't it work for inequalities? Because they're not equations. Because inequalities have this rule that says when you multiply by a negative, they switch positions. And I don't know if you can't multiply by a variable unless you know it's positive or you know it's negative, so you know whether or not to switch the sign. So this is kind of the source of most errors in solving inequalities. You guys want to treat them like equations, but yet you don't realize, oh, wait a minute, I have this issue that if I multiply or divide by a negative, I have to switch the sign, which means you have to know if you're multiplying or dividing by a negative. All right, so these are pretty easy. I mean, these are still linear, so it doesn't really start getting really complicated until we get to the more complex inequalities, but this is pretty straightforward. Can I subtract 2x over to this side? Does adding or subtracting bother me at all? Nope. So I subtract the 2x, combine my like terms, subtract your 2 over to that side, negative 10. My preference is I like to have, well, we can divide by 5. Is that dividing by a negative? So I shouldn't switch the sign. But I don't like to have the x on that side. Can I reverse it? X is less than negative 2. So I have solved it. I have gotten the answer. But usually they want you to write your solution as a solution set. So we got the inequality answer to be this, which graphs a number line solution set of, here's my negative 2, and we are going to shade which way, left or right? Left. Open or closed? Open. So open, shade to the left. So that's a picture of my solution set on the real number line. My interval notation, negative infinity to negative 2. My set notation, x such that x is less than negative 2. Typically you don't do all 3 of those. It's just we're practicing, so we're just throwing them all on there. Does it bother me to see something like this? Can you simplify expressions on either side of an inequality just like we did with equations? Yes. So 3x minus 3 plus 2 less than or equal to 5x plus 6. Combine like terms. 2x less than or equal to, and then you guys can start doing a lot of stuff in your head. These are not hard. Negative 3 plus 2 is 1 minus 6. Negative 5, x is greater than or equal to negative 5 halves. And then again, I like to reverse it. Oh, did I make a mistake? Because when you reverse it, you have to actually keep the inequality correct. So greater than or equal to. So my inequality that we found is our answer. Yes. Negative 1. Oh, it is negative 7. Boy, I'm just terrible today. Terrible. I'm always terrible. Arithmetic is always my negative 7, right? And then negative 7. And we'll change this one. All right, so which way do I shade my solution set when I draw the picture on the graph? To the right. And what should I do at this negative 7 halves? Square bracket to closed, shade. Your interval notation, bracket, negative 7 halves to infinity. And then if you had to write it in set notation, x such that x is greater than or equal to negative 7 halves. See, these are nice and easy. Oh, compound inequalities. All right. This is a simple compound inequality. We do not have to separate this into 2 separate things to solve because it's a conjunction. And it's a conjunction where the x is only here in the middle. Okay? Your objective is, after you solve this, to get x in between what 2 numbers? So you're basically solving for x, but you have 3 parts to look at. Can I subtract 1 from each of these 3 parts? Yeah. Subtract 1, we get negative 4, less than 2x, less than or equal to 7 minus 1, 6. As long as you do it to all 3 parts, we can keep them together. All right? Now what do you think I should do to solve for x? Divide by 2. As long as you divide each piece by 2, so x is greater than negative 2 and less than or equal to 3. So do you see that what you're doing is just trying to get the x in the middle so that we have this answer that is a nice, easy conjunction? So what would the graph look like? Which way do I shade? Conjunction shades in between. What goes at -2, open or closed? Open, shade, closed. Okay. We like it when our answer is one of the basic ones. All right, and then my interval notation, -2 to 3, bracket. And notice I didn't even ask for a set notation because most of the time when we do these solution sets, we draw the picture and then we usually do interval notation unless we can't. All right, be careful when you have these compound inequalities. Again, kind of a check that you should probably do before you start solving this. I didn't say it up here on this one, but you guys should check and make sure that this makes sense, right? That you have a compound inequality, that you have a number that's smaller, less than, a number in the middle, less than, a number in the middle, that you won't order in these. So you do want to make sure that that makes sense before you start to solve it. Okay, and that makes sense. I have 5, which is smaller than this, which is smaller than 11. What if I had 11 smaller than this, smaller than 5? What would you say immediately right there? Is there any way anything can be in between? You can't have that. So you have to make sure it makes sense to start the problem. It's like saying distance equals a negative number. Distance can't equal a negative number. So we're checking to make sure we have a inequality that makes sense before we do the problem. Add 1. 6 less than or equal to -3x less than or equal to 12. Now what do you have to be careful of? You got to switch the sign. I'm going to divide by -3, which means I have to switch the sign on both of them. So 6 divided by -3, -2 is now going to flip over to the other side of where it was. And then x, and then switch your sign. 12 divided by -3 is -4. And don't leave it like this. Why do I not like it in that notation? I want it in order, so I automatically go small to large, so I'm going to flip it. -4 is less than or equal to x, which is less than or equal to -2. And does this make sense? Is -4 left of a number that's left of -2? Okay, so if we've done this correctly, and it started out with something that made sense, it should end up with something that makes sense. So my solution set, -4, -2, I'm shading in between with closed brackets. Usually the mistake happens, y'all get to here, and y'all go -2, -4, and then you shade in between, and then I'm going to mark off, because -2 is not to the right of, -4 is not right of -2, it's the other way around. So put yourself in order, smallest to greatest, and our interval notation, -4 to -2. These are easy, don't get tripped up by weird cases when you're doing it. Alright, now, take a look at this. That doesn't make sense. Let's see what happens if I didn't notice that in the beginning. You should immediately notice that there's no way that -3, because of the transitivity, this is what you're basically saying, -3 is left of 2x plus 4, and 2x plus 4 is left of -7 and. Let's see what happens when we try to solve it. Subtract 4. We get -7 less than 2x less than -11. We subtract, or divide by 2, -7 halves less than x less than -11 halves. And you're all like, hey, I have an answer. What do you guys do? Because you haven't paid attention? Y'all want to do this? And then start shading in between? Does that make sense? What's -7 halves? What number is that? That's -3 1/2. What's -11 halves? -5 1/2. Does that make any sense? No, that's not the correct location. This should be the -11 halves. This is the -7 halves. Can a number be bigger than -7 halves and smaller than -11 halves? And there's no way. You should have known from the beginning that that was a bad problem. You really shouldn't do any of this work at all, because you should be like, wait a minute, -7's not left of, or -3's not left of -7. That's a no solution problem. I don't have to do any work for that. So there should be nothing on my number line, and my, what should I do for interval notation? Well, that's not interval notation. Can you write? You can't write interval notation. So this is not applicable. The only way to write this is with set notation, because the answer is null set or empty set. No solution. And I want to train you to figure out that there's no solution before you start. Don't get tripped up by these. Alright, so on this, want y'all to do the group work and see what you do for this. Now notice that some of these, I have them written where you have separate ones, so it's not a conjunction. You should solve and then see whether or not it simplifies. Is it a disjunction, or does it simplify to something else? Solve the conjunction. This one is and, solve this, and then remember it's and see if you can put it together into a conjunction. And is intersection. And for each of these, you're going to graph and then state it in interval notation if possible. If not possible, give me a set notation for it. All right, in about 5 minutes, we'll do a key and check your answers on it. All right, so your first one, check your answer on the first one.